Okay, so we're going to be focusing on properties of logarithms today. We are going to be revisiting properties of exponents and using that as a base for properties of logarithms, since those are inverses. Now, if we begin by looking at the warm-up, we should be able to answer these using the properties of exponents. So starting with A, 5 to the third times 5 to the what would give me 5 to the sixth. What do we think would be the missing exponent for this one? 5 to the third times 5 to the what? 5 to the third. So watch what happens. If I make this 5 to the third times 5 to the third, what's going to end up happening is we can add the exponents. 3 plus 3 would give us 5 to the sixth. Right? Okay, then we have the following. 5 to the eighth divided by 5 to the something equals 5 to the fourth. What exponent would we be missing from example B? 2. So we're thinking 5 to the eighth divided by 5 to the second gives us 5 to the fourth. Let me remind you, when you have the same base and you're dividing the same base, you're not going to divide the exponents, you're actually going to subtract them. So with that in mind, the missing exponent should be a 4. So 5 to the eighth minus 4 gives us 5 to the fourth. So the missing exponent is a 4. All right. Next, we have 2 to the something raised to the fourth equals 12. 2 to the 12. Whenever you have an exponent raised to another exponent, let's see. There are 4 math operations, right? We already did addition. We already did subtraction. So it's either going to be multiplication or division. What do you think is the two of these? Multiplication. So we're going to have 2 to the something times 4 equals 2 to the 12. So that something would be a 3. 2 to the third to the fourth equals 2 to the 12. Okay. All right. For the next ones, let's actually solve these out. Log base 2 of 4 plus log base 2 of 8 equals log base 2 of blank. Well, log base 2 of 4, 2 to the what power gives you 4? 2 squared gives you 4. 2 cubed gives you 8. So 2 plus 3 is 5. That means we want to figure out, okay, log base 2 of what to the 5th power? In other words, 2 to the 5th is equal to what? So once again, because log base 2 of 4 is 2, I'm explaining it. Because log base 2 of 4 is 2, log base 2 of 8 is 3, that means that the exponent for the remainder, this log 2 right here, the exponent will be a 5. So 2 to the what? 2 to the 5th gets you what? That's how we're going to find the question mark. 2 to the 5th power gets you 32. Okay? So that was a lot of steps, but I hope I didn't lose you there. So I got the 2 and the 3 from evaluating these logarithms. Log base 2 of 4 is 2, right? Because 2 squared gives you 4. Log base 2 of 8 is 3, because 2 to the third is 8. Then, because I'm adding these, I know, like 2 plus 3 is 5, right? So I know that 2 is going to be 2 to the 5th to find the missing answer. 2 to the 5th gets us 32. So that's what the missing value would be for this. Okay, that's what the question mark is. Okay. Log base 2 of 128 minus log base 2 of 64. All right, let's do the same thing. So let's evaluate this. Log base 2 of 128. 2 to the what power gets you 128? 2 to the 7th. And then log base 2 of what gives you 64? That's a 6. So we have 7 minus 6 if we're evaluating that. 7 minus 6 is going to equal 1, right? So we're saying, okay, we're saying log base 2 of something equals 1. Now, when you rewrite it like this, log base 2 of something equals 1 means 2 to the 1 gives you that missing value. So what is 2 to the first power? No, 2. Yeah, so the question mark is actually a 2. Now this probably doesn't make sense to you because I see a lot of confused faces. We're going to explore properties of logarithms and we're going to actually see the behind the scenes of why this works. We're not going to actually do it this way when we do it moving on. But this is how you would solve it if you didn't know how to apply the properties of logarithms. All right, so if it doesn't make sense to you, don't stress too much about it. Okay, log base 2 of 4 to the third equals blank log base 2 of 4. All right, log base 2 of 4 to the third is the same as log base 2 of 64, which equals question mark log base 2 of 4. Let's evaluate each one. Log base 2 of 64 we know is 6. And log base 2 of 4 is 2. So what would the blank be equal to make this a true statement? 2 times what gives you 6? That would have to be a 3. So that means that the missing value is a 3. Right? Because 2 times 3 is what gets you 6. Okay. Now, I can see it in your faces. You don't know what's going on. We are going to walk you through properties of logarithms, which is going to make more sense. Now, this is just a warm-up. And in this warm-up, the reason why I guided you through this was because I obviously know a little bit more than regarding this than you guys, because obviously you haven't seen this yet. So that's why I was walking you through it. Anyway, so let's actually look at some notes, and hopefully with these notes, you should be able to feel more comfortable with what's going on. All right. So first, let's look at the properties of exponents that we saw last semester. When you multiply the same base, we talked about this fact of being able to add the exponents. So something like x to the value of m times x to the value of n can be rewritten as x to the value of m plus n. If we actually introduce some numbers, like the example below, x to the third times x to the fifth can be rewritten as x to the 3 plus 5 power, which equals to x to the 8th. Okay? So all we're doing there is just applying that property of exponents, where we will be adding the exponents together, assuming that we're multiplying the same bases. Right? Now, because the logarithm is the inverse for an exponent, we're actually going to do a different approach. What's going to end up happening is if you're adding the same logarithms, then you can actually multiply the inputs. And this is what I mean. So log base b of x plus log base b of y, since we're adding the logarithms of the same base together, then we can actually multiply the inputs. And then when I say inputs, I'm referring to what's inside of the parentheses. So log base b of x plus log base b of y is the same as log base b of x times y. Right? So log base b of x times y. Log base 6 of 5 plus log base 6 of 7, now using the same, using some numbers instead. Log base 6 of 5 plus log base 6 of 7, we have log base 6 of 5 times 7, which is equal to log base 6 of what? What's 5 times 7? 35. Okay. All right, so then moving on to quotient property for exponents. So now when we divide the same base, we saw last semester that we can actually subtract the exponents from one from the other. So x to the m minus n. So with actual numbers, x to the 6 over x squared is the same as x to the 6th minus 2, which is x to the 4th. Okay. So how does that translate to logarithms? Well, it translates to logarithm in the sense that if we're subtracting one logarithm from the other, then we can divide the inputs as well, like this. Log base b of x minus log base b of y is the equivalent of log base b of x over y. All right, log base b of x over y. And if we actually introduce some numbers to the mix, then we can do the following. Log base 5 of 30 minus log base 5 of 10 can be rewritten as log base 5 of what over what? Log base 5 of, what's the first number? 30. Second number is 10, so 30 over 10. What does 30 over 10 reduce to? 3. So we can rewrite this as log base 5 of 3. Okay. All right. Finally, the last rule that we're going to look at for today is going to be the power property. And so the way that the power property works is the following. With exponents, whenever you have an exponent raised to another power, then you can actually multiply the exponents together. So we get x to the, x to the m times n power, like that. Okay, and then with some actual numbers, x to the third times, or raised to the second, could be the following, x to the third times 2, which 3 times 2 gives us 6. Okay. All right, now how does it work for logarithms? It's different, I'll tell you that much. It's not really a direct translation, but this is what happens. With a logarithm, you're actually going to take that exponent that's inside of the input and you're going to bring it out to the front. So log base b of x to the y becomes y times log base b of x. Y times log base b of x. All right. So with some actual numbers, log base 3 of 5 to the 4th becomes, well, if we bring the 4 to the front, 4 times log base 3 of 5, like that. Okay. And so this is a property that goes both ways. If you have a coefficient, meaning a number in front of the logarithm, then you kind of have to throw that back into the mix. All right. So either you're taking it out of the input or you're putting it back into the input. And I'll show you some examples with some actual numbers in just a second. All right. So do me a favor, and under properties of logarithms down here, we're going to go ahead and label the first one the product rule or the product property, just so you guys know what each of these are called, so that when we refer back to them, you know which one we're using. So top left is product, middle is quotient, and top right is the power property. Okay. Now, as we solve the first one, I'm going to be kind of labeling what property I'm using, so that you guys know which one it is that we're using. So, for example, log base 7 of 2 plus log base 7 of 15. Here, because we're adding the same base of log base 7, we can actually use the product rule and rewrite this under a single logarithm. Log base 7 of, what am I doing with the inputs when I use the product rule? Look what's happening here. Are we going to add the inputs together, or what are we going to do here? What do we think? We're going to multiply them. So it's going to become 2 times 15, which is going to equal log base 7 of 30. And that'll be our solution, log base 7 of 30. So all we're doing is we're just simplifying. We're not actually going to solve these. Most of them cannot be solved in the sense that you won't find like a whole number that goes into them. You might for a few of them, but not all of them. So like in our case, we don't know what 7 to what power gives us 30 because that's not a perfect square. Okay. Next, you will probably see ln, and ln is just the same as a regular logarithm. It doesn't really change how you solve it. For this problem, first, we're actually going to use the power rule because we have that 2 as a coefficient for 2 ln of 6. And so how we're going to rewrite this is the following. We're going to write this as ln of 2 plus ln of 6 to the second power, like that. Remember that any coefficient we can throw back into the mix as an exponent. All right, so now we can actually use the next rule, which is the product rule. And now, because we're using the product rule, since we're adding the same logarithms, we can multiply them together. So ln of 2 times, what is 6 squared? 6 times 6 is 36. So we have ln of 2 times 36, which is going to simplify to ln of, what is 36 times 2? Double 36, what do we get? What is it? 72. So we get ln of 72 as our final solution. Okay. All right. You're going to try only number 1. I don't want you to try out number 2 yet. We're actually going to skip that one for now because it shows up again later. So skip the second one. Just try the first one. Let's see what you can do. Take about, I don't know, 10 more seconds. Log base 5 of 8 plus log base 5 of 6. What rule are we going to use here? Let's check in. What rule? Let me hear from Sophia. What rule am I using for number 1? Product. Okay, product allows me to rewrite this as log base 5 of what? Log base 5 of what? Salvador. Log base 5 of what? We're using the product rule. What are we doing with the inputs? Salvador, look up here. Look at the last one we just did. We had 2 times what? Look at the input. Inside the parentheses, we have 2 times what? No, not 7. Look at the input. Salvador, look up here, not at your friends. 2 times what? Huh? The screen's up here. 2 times 15. So down here we're going to have Salvador. What are we going to have? 8 times what? It's okay. We're going to wait till you get it. 8 times what? 8 times 6. Thank you. 8 times 6. Okay. So 8 times 6 is going to equal, what's 8 times 6? 48. Log base 5 of 48. So that is the product rule. Now let's look at the quotient rule and see how that affects the work that we do. So in the next example, example 2, you'll notice that we are subtracting the logarithms one from the other. So this is an example of quotient rule. And so what that allows us to do is we can rewrite this under a single logarithm as 24 divided by 6, which is going to result in the following. Log base 3 of, well, 6 goes into 24 4 times. So log base 3 of 4, I mean. Okay? So we get this as our solution. All right. Now, when we look at ln, 3 ln 2 minus ln 4, well, here we can't just go directly into quotient rule. We have to do the power rule first. So this is power rule first because of this 3. We'll throw that 3 back into the input. Ln of 2 cubed minus ln of 4. So ln of 2 cubed will be ln of 8 minus ln of 4. And it's at this point that we can actually use the quotient rule. And so what's going to happen is we can rewrite this as ln of 8 over 4, which will equal ln of 2. Okay. All right. I'm going to give you a few minutes to try out numbers 3 and 4 down below. So go ahead and take care of that right now. All right. So let's look at number 3. What property will I use for number 3, Paulina Castillo? Quotient property. Good. This is the quotient property. And I'm going to rewrite this as log of what? Josiah, log of what? Eight over 2, which will equal log of 4. So solution is log of 4. Okay. All right, next example. This one's more challenging. First, before we do the quotient rule, we have to do the what rule, Aiden? Before the quotient rule, we have to use another one. The power rule. So power, that means we're going to take that 3 and throw it back into the mix. Log base 7 of 4 to the third minus log base 7 of 2. Now I can use the quotient rule. I'm going to get the following. Log base 7 of, what is 4 to the third? 4 to the third. 4 times 4 times 4 is 64 over 2, which equals 32. Log base 2 of 32 is our final solution. All right, there is one more example I'll show you. Then I'll give you some time to do some work on your own. All right, example 3. Let's make it just slightly more challenging at this point. 1/2 log base 3 of 36 plus 3 log base 3 of 2. So as you can tell, we have quite a few coefficients here. We have a half as a coefficient and we have a 3 as a coefficient. So we must use the power rule for both of these. And so I'm going to get the following. I'm going to get log base 3 of 36 to the 1/2 power plus log base 3 of 2 cubed. And so the way we're going to solve 36 to the 1/2 is the following. So 36 to the 1/2 means we have 2 groups of the same size that multiply to 36. That is what it means. It means we have 2 groups of the same size that multiply to 36. So what should each group be made up of? 6. Now, of these 2 groups, we only want one of them. That is how we get the 1/2. We only want one of them. So 36 to the 1/2 will equal 6. So we're going to get the following. Log base 3 of 6 plus log base 3. What is 2 cubed? 8. Now we're going to use the product rule. Log base 3 of 6 times 8, which equals log base 3 of 48. And so this right here is going to be our solution. I know I'm running out of space. I'm sorry if it's hard to see. I'll walk you through again how I got this. So log base 3 of 36 to the 1/2. 36 to 1/2 is 6. 2 cubed is 8. Log base 3 of 6 plus log base 3 of 8. We use the product rule. Allows us to multiply the 6 and the 8 together to get a solution of log base 3 of 48. Okay? Are there any questions with how I got those two solutions? We all good with that? Okay, let me do one more example and then we are going to be done for today. All right, ln 48. ln 48 minus 1/3 ln of 8. So because we have a coefficient of 1/3, that is going to be the power rule. And so we're going to rewrite it as follows. ln of 48 minus ln of 8 to the 1/3. Now think about what 8 to the 1/3 is asking. It's saying 3 groups of the same size multiplies to 8. So what times what times what gives you 8? 2. That means you have 2 times 2 times 2, but we only want one of these. So this is what's going to happen. You're going to get ln of 48 minus ln of 2. What rule can I use for ln 48 minus ln 2? Nope, not product. We're not adding these. Quotient. Because we're subtracting this as quotient. We're going to get ln of 48 divided by 2. Half of 48 is 24, and that will be our solution. Okay. All right. We will check in a few minutes. So go ahead and try the next one you're on. When you're ready, you can check your work for the first one. If you're done with the first one, try the second one. I will post the solution in just a second. Okay. When you're ready, you can check your answer for the last one. Okay. All right. So I'll leave this up here. This concludes the guided notes portion, and then the remainder of class, you're going to work on the next 6 questions.